A thin spherical shell of total mass m and radius r is held fixed. There is a small hole in the shell. A mass m is released from rest at a distance r from a hole along a line that passes through the hole and also through the center of the shell. This mass subsequently moves under the gravitational force of the shell. How long does the mass take to travel from the hole to the point diametrically opposite? Okay, so what will happen over here? Okay, now first of all, let me take a shell. Okay, this is a shell and not a solid sphere. Okay, let me take a hole along this point, and this is the center O. Let me draw a line, and there is a point. Okay, there is a point. Let us take this point P, which is at a distance r from the shell. Okay, r from the surface of the shell, and the center over here is equal to r. Okay, so basically inside the shell the electric field is equal to 0. So if the gravitational field is equal to 0, so if the gravitational field over here is equal to 0, there will be no acceleration due to gravity inside the shell. So when the body of mass m will be only accelerated as it moves from point P to, let this point be A, the surface, the point along the surface, let it be equal to A. So the body will move only from point P to A. After that point it will not move, it will not accelerate, okay, beyond point A to point B. Let AB be the diameter of the shell. Okay, so let us find out the acceleration of a body. Okay, and acceleration of the body and the velocity of the body by the time it reaches point A. Okay, so first of all, the acceleration due to gravity is given as, the acceleration due to gravity for a shell, it will be given as gm divided by r square, where r is the distance from its center. Okay, now this is the acceleration due to gravity. This formula of acceleration due to gravity is valid only above the surface. Okay, at a certain height or altitude above the surface of any planet or any shell or any body. Okay, so basically this acceleration due to gravity goes on varying as per the distance or as per the height above the surface of the planet. Okay, so let me say that at this point the velocity was equal to 0. At this point, when at point P the velocity was 0, at point A it has certain velocity. Let the velocity be equal to VA. We have to find out the velocity of VA, because VA will be equal to VB, because there is no acceleration or deceleration inside the shell. Okay, VA will be equal to VB. Okay, so basically small g, that is the acceleration due to gravity, will be equal to gm divided by r square. It will be equal to gm divided by r square. Let me say that the body arrives somewhere in between when its distance is equal to x. Okay, when its distance is equal to x. In that case, the acceleration of the body will be equal to gm divided by x square. Okay, it will be equal to gm divided by x square. So the velocity of the body, the acceleration can be given as velocity, differentiation of velocity divided by time, okay, is equal to gm divided by x square. But if you see, the variable over here is x, so the same formula can be written as, this is x square, the same formula can be written as v dv divided by dx is equal to gm divided by x square. Okay, gm divided by x square. Okay, so v dv will be equal to gm by x square into dx. Now if I integrate on both the sides, it will be equal to, from v to dv, so it will be equal to v square divided by 2. We will see the limits later. Okay, it will be equal to gm will be constant, it will 1 by x square will be equal to minus 1 by x. Okay, we will see the limits later. Okay, now this is how we will get the velocity of the body as it reaches the surface. Okay, now at a distance x, okay, initially the initial distance was x, initial distance was 2r, and the final at point P the initial distance was 2r, and when it reaches point A its distance was r from the center. So the limits are from 2r to r, and its velocity when it was at the point P was 0, and the velocity at point A is unknown. So it will be equal to 0 to VA. So basically it will be equal to VA square divided by 2 is equal to gm into minus 1 by r plus 1 by 2r. Okay, minus 1 by r plus 1 by 2r. Okay, this will be the formula. Okay, this will be the formula. So basically it will be equal to VA square divided by 2. It will be equal to VA square divided by 2. Okay, it will be equal to, since the acceleration over here is in the direction, so it will be equal to gm into it will be equal to minus 1 by 2r. Okay, it will be equal to minus 1 by 2r. If I only want the magnitude over here, okay, it will be equal to BA will be equal to 2 and 2 will get cancelled out over here, will be equal to root gm divided by r. If I only want the magnitude, the negative sign will get cancelled out, so it will be equal to gm divided by r. Okay, now this is the velocity as it reaches point A. Okay, from A to B there is no acceleration, so I can say that the displacement over here is equal to 2r. Okay, displacement is equal to velocity into time. Since there is no acceleration, displacement is equal to velocity into time. So displacement is 2r, velocity is root gm by divided by, it will be equal to root gm divided by r. Okay, it will be equal to into time. So time over here will be equal to 2 root. Okay, it will be equal to 2 root. Okay, I will shift this on the left hand side. It will be equal to r cube divided by gm. Okay, so they have asked in the question, how long does the mass take to travel the hole to the point diametrically opposite? So it will be equal to 2 into root of r cube divided by gm. Okay, it will be equal to 2 root of r cube divided by gm. Okay, which is the time required to for the particle to travel a distance, that is the distance equal to the diameter of the planet or any spherical shell.